Systems of linear inequalities in two variables. Linear means we're going to have a straight line. Inequalities means we're going to have greater than, less than, greater than or equal to, less than or equal to signs where we have been working with just equal. Two variables, since we're working with the Cartesian coordinate, we're going to have x and y. So let's solve for it. I'm going to label these A and B, so I'm going to keep it separated. And I'm going to graph A here, and I'm going to graph B here. So let's do that. So in order to graph A, I want to find the intercept. Where does it cross the x-axis? Well, I know y is 0 anytime I cross the x-axis. So I'm going to plug in 0 for y. And that gives me x is greater than or equal to 6. That worked out great. So let's plot it. Start at 0, 0, and go to the right. 6, 1, 2, 3, 4, 5, 6. Because x is positive, I went to the right. Now let's find y intercept. Well, when we cross the y-axis, I know x is 0. So let's plug it in. So now y is greater than or equal to 6. And let's go plot that order pair. Let's go back to the origin 0, 0, and let's go up because y is positive. 1, 2, 3, 4, 5, 6. And I'm going to connect this line, connect these dots, make it my straight line. Now let's come over here and do B. So let's find its x-intercept. So I'm going to plug in 0 for y. And I get 2x is greater than or equal to 0. I'm going to divide by 2 because I need a positive 1 coefficient on x in order to know what x is. Remember, if it was a negative that I was dividing, the inequality would have flipped. But in this case, it was positive, so we didn't change it. Anytime the numerator has a 0 in it, our answer is 0. So that means it's 0, 0. It's x and y intercept. It crosses the center of the graph. So I'm going to have to find some other points on this graph that's on this line. So what I'm going to do is I'm just going to pick some point. It doesn't matter if it's the y or x you use, but it's like creating an XY table. So let's just pick a point. I'm going to pick a point over here. Let's say 2 for x. Let's let x equal 2. So I got 2 times 2 minus that y is greater than or equal to 0. So 2 times 2 is 4. And then let's subtract 4 from both sides because we want y by itself. So I got negative greater than or equal to, or negative y, sorry, greater than or equal to negative 4. And I need a positive 1 coefficient on that y, so I'm going to divide by negative 1. And remember, whenever we divide by negative, forcing it through the inequality flips. Negative divides negative is positive, so I get 4. So this order pair is 2, 4. So I'm going to come up here and plot it. I'm going to go to the right 1, 2, up 4. 1, 2, 3, 4. So now I could draw this line. If I had another graph right here, which I should have had one for us so we can overlap them and shade the area, but let me grab one here in just a minute. But for right now, let's do this. Let's do the next part. Since we are talking about inequalities, we got to figure out what part of the graph is true for that equation. So since they're both greater than, we can look at the top above the lines and see, do they make a true statement? If it was less than, so I'm looking only at A right now, guys. So since it's greater than, it says all my values have to be greater than 6. I'm going to focus on the top part. If it would have said all my values is less than, I would have focused at the bottom. But however, I need to pick some order pairs and check it, see if it's true. So any order pair above this line, so what do we got? Let's go with 3, and what's above it? 1, 2, 3, 4, 5. Let's go 3, 5. And let's plug it in. So I got 3 plus 5 is greater than 6. That's 8 is greater than 6. So true. So I'm going to shade this part of the graph because all these points on this part of the graph is going to make that equation true. Now let's come over here and find for B, what's true for B. Well, B again says it's greater than, so we know that it could be this top part right up here. So let's focus on it. All right. So let's pick any point over there. And what I notice, or any point above it right here. So we can say 1 for my X, right? Right here, 1. And let's go up 7 for Y. And let's plug it in. So I got 2 times 1 minus 7 greater than 0. 2 minus 7 greater than 0. What does that give me? It gives me a -5. That's not greater than 0, so that's false. So what I'm going to do is say, okay, I am not focusing on that area. Let's look on the area on the other side of that line. So let's come over here and let's pick 2, or let's do 3. Why not? Let's do 3, comma, how about -2 for Y? Let's plug it in. 2 times 3 minus that -2 greater than or equal to 0. 2 times 3 is 6. Negative times negative is positive. And I get 8 is greater than 0. So true. So all these values on this side of this line is going to make a true statement with that equation. So now this is where I need the overlap. This is where I need the other graph where it's kind of, let me take a picture and kind of paste it right here. Let's see if they'll let me bring it back up here. No, it's not going to let me. So what we're going to have to do is memorize. Okay, so we've got order pair 6, 0, and 0, 6. Let's graph that right quick. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have this line. All right. Now let's look at this other one. We said 0, 0, and then we got 2, 4, right? 0, 0. 1, 2, 1, 2, 3, 4. My drawing would have been a little bit better. They would have intersected that 2, 4. All right, now we said for A, everything in that right-hand corner, and B was that right-hand corner down. So that means what's going to be true for both lines is going to be right here. Just this particular point right here. These points. So that's where we shade on that one. So again, if my line would have been a little straighter, we would have saw that they intersect at 2, 4. 2, 4 is called the corner point. Okay, it's the corner point in the solution region. And this is what it talks about right here. Okay, so now let's solve for our next example. The next example is we're given 3 equations. We're going to have to shade it. It's going to see if there's a way to go ahead and copy and maybe get another graph right here. So we can use one for shading. Let's do this. All right. So what we need to do, and you can label it however you want. I like calling it A, B, C, and this is B, and this is C. And we may need to make some room because you can see there's 50 and 22. There's not going to be, this is a 10 by 10 graph. So you're going to want to use a full sheet or a bigger graph for sure. So let's get this done right here. Give me some space. Let me rewrite this. Now, that last graph is going to be where we overlap them. All right. So on A, I'm going to make my intercepts. I'm going to say I got x-intercept. I know I plug in 0 for y. I get 2x is less than or equal to 22, divide by 2, and it gives me 11. So that order pair is positive 11. So I'm going to come out here because it's a 10 by 10 graph. Now let's find its y-intercept. Well, I know x is 0. So when I do that, I plug in 0 for x, right? I get y is greater than or equal to 22. So it goes there. So this is a 10 by 10. So right here is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 22. So yeah, it's not going to be the best looking graph, but it's close. Again, you may want to use a full sheet, bigger graph. All right, so that's A. Well, now we need to determine what points are true. Well, it literally says it's less than. All points has to be less than that 22. Well, if you're not sure, you can go ahead and pick points. But I'm going to just tell you, if you're going to start off doing that, pick the points below the line because we know those are negative values. So let's just do that. And I'm going to pick 0, 0 because it's not on the line and that's the easiest to do. If I pick 0, 0 and I plug in 0, I get 2 times 0 plus 0 is less than 22. That's correct. 0 is less than 22. So I'm going to shade everything below this line because I know all those values make it true. So now let's find B. So whenever we whenever we graph B, we're going to find its x-intercept first. So I'm going to plug in 0 for y. That gives me x is less than or equal to 13. So I'm going to have to come out here 1, 2, 3, right here, it'd be about 13. And then let's do its y-intercept. That means x is 0. Well, if x is 0, then that means y is less than or equal to 13. So I'm just plugging these in, guys. If you need these extra steps, I would put in the extra steps. All right. Now let's connect those lines, those dots, making that line. And now let's determine. Again, it says that it's less than, so it should be everything below it. Let's check it. Let's use 0, 0 since it's not on that line. Well, 0 plus 0 is less than 13? Yes. So I'm going to graph all these points below it. All right, now let's do C. Find its x and y intercepts. So when I plug in the x-intercept, I plug in 0 for y. So I get 2x is less than or equal to 50, and I just put 0 in for y and it went away. Divide by 2, I get x is less than or equal to 25. All right, so I need to go out. 1, 2, 3. Well, it's going to be a big one, so about right there. All right, now let's do the y-intercepts. Means I plug in 0 for x. That gives me 5 y is less than 50. I would have times the 2x by 0. Divide by 5. 5 goes into 50 10 times. So I get this spot right here. And let's connect those dots. And again, you notice it says less than, so I'm going to say we're going to shade this here, but you want to make sure. So I'm going to pick 0, 0 because it's not on the line. So if I plug in 0, 0, that says 0 is less than 50. Yes, that's true. All right, so we are good so far. So we got this graph here. Now, if I was to put them all on the same graph, and I erase my order pairs, guys. So what do we got here? We got 22. So I'm going to, instead of putting it on this graph here, let's take A and put A and B on C since C is so far out. And we're just going to go, let's see, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And it went down to 11. So let's do that. And let's do B. B was 13 and 13. Okay, so my drawing was not great. So we want to pick the points that's true for all of these lines. So it would literally be below right here because you would not want to put it in between. I mean, it would be wrong if you put it here because it's only true for one of the equations. It has to be true for all three. So we agree that it's all going to be this lower part. And the point, corner point here will be where they intersect at. And since we got these three things going on, drawn correctly, which it wasn't drawn exactly to par, then we would have saw that the line actually, like this one line, line A crossed line B right in here, and line C crossed line A. We would have got these points in here where they crossed, and it would have been a lot better. So I would use a graphing calculator or a full graphing sheet where you can draw it out. But as you notice here, the solutions here where we would have got a more accurate reading, we would have got where the corner points actually met at 5, 8, and 9, 4. And there was only 2. It's just my lines here got off a little bit. Okay. And it's not a corner point because there's multiple things going on here. We don't have just one point, so we wouldn't call it the corner point. So now let's do our next one. Our next one's talking about bounded and unbounded regions. Example 3, is an application problem. A patient on a brown rice and skim milk diet is required to have at least 800 calories and at least 32 grams of protein per day. Each serving of brown rice contains 200 calories and 5 grams of protein. How many servings of each food should be eaten per day to maintain a minimum daily requirement? So what I'm going to do is I'm going to draw me a table and label it. So let's do that. So we are talking about calories versus protein. And then we have the rice, and I'm going to call that X. And then we have the milk, and I'm going to call that Y. And then we have a minimum daily requirement. So let's label it now. So it said on the rice, it was 200 calories, right? And if we notice that we were missing a sentence here, we have on this, we have the 200 calories for the rice. Okay, so the milk sentence was missing here. We have 800, contains 800, excuse me, let me say this right. This milk contains, I was looking at the number above it, 80 calories, and it has 8 grams. So we're going to put that here. All right, and the minimum says 800 calories to 32. All right, so now let's write our equations out. We have 200x plus 80y, and we're going to say it is greater than, because it says at minimum, this is the requirement. So that means we can take more than that. And the same way for the next equation. All right, so now we're going to graph it, and we're going to determine their corner points if they have them. So what I want to do now is put me a graph here. Let's copy and paste that graph there. All right. It moved my writing here, so we'll just redo this and let's erase this writing here. All right, let's solve for it by plotting its x and y intercept. So the x-intercept, y is 0. So that means I get 200x is greater than or equal to 800. Divide by that 200, and I get 4. X is greater than or equal to 4. So plot it. Go to the origin, go to the right 1, 2, 3, 4. Now let's find its y. So x is 0 when I do that. So I got 80y is greater than or equal to 800. And divide by the 80. And we get y is greater than or equal to 10. So let's plot it. And we can connect those dots. Now let's do the same thing for the next equation. So that means y is 0. So divide by 5. So that gives me what, 6.4? So I'm gonna come over here and go 1, 2, 3, 4, 5, 6, and just a little bit past it, almost halfway. And then let's do the y-intercept. 0 for x. I get 8y is greater than or equal to 32, where y is now, because I divided by 8, is 4. We're going to go 1, 2, 3, 4. Oops. Okay, so now you see that there's going to be 4 regions all the way around this here that could possibly be true. I'm going to go back and read it, and if you notice, they both say greater than. So I'm going to start with this region first. If it's not true, I'll work my way around it. Let's just check it. So when I check that region, I'm going to clean this up where I can have some room to write. I'm going to pick some order pair in there. So let's just pick, how about 7 for x, somewhere's in here. And we can do 7 for y because it's up here. And let's plug it in. So I got 200 times 7 plus 80 times 7 greater than or equal to 800. And let's multiply this out, which is going to make sense because 200 alone times that 7 is going to be 1400. And then we're going to add another number to it. So I'm going to say true for that equation. So let's do the next one then. Greater than or equal to 32. Well, 5 times 7 is 35. And then I'm going to add this to it. It's already larger, so it's true. So I'm going to say this area here is true for both of them. The point of where they actually cross and intersect at, if you notice on your graphing calculator, it's going to be way better than what I came up with, but the actual answer is 3.2, 2. That is my corner point.